Now, there are two methods which are used for converting the independent variables involved in physical phenomena into independent dimensionless terms. So, we shall study only the one method that is in our syllabus, which is known as Buckingham's pi theorem. This was developed by Buckingham, that is why in his honor this theorem is known as Buckingham pi theorem. Buckingham pi theorem states that in any physical phenomena, if there are m number of independent variables like x1, x2, x3, xn, then analytically this may be expressed as function of x1, x2, x3, xn is equal to 0. Right. Let me give example again. Suppose we are in a room where this fan is used to impart velocity to air. This phenomena may be function of RPM of the fan, density of the air, viscosity of the air, angle theta, angle of the blade, maybe number of blades, right. So, let us say it is function of these number of independent variables. So, we must have the knowledge that in this physical phenomena, what are the independent variables playing important role. So, in this phenomena, this is RPM, density, viscosity, angle of tilt of blade, then number of blades, etc. If we consider only 5 variables, then this phenomena mathematically may be written as function of these equal to 0. We do not know the exact relationship among these independent variables involved in this physical phenomena. So, suppose here we have any physical phenomena where we have these number of variables x1, x2, x3, xn, and mathematically this may be written as function of this is equal to 0. Now, if these n number of variables required to be described by m number of fundamental dimensions, m number of fundamental dimensions. What are the fundamental dimensions? Like mass, length, time, length, theta, etc. Generally, we deal with these 4 only in our fluid mechanics. Generally, these are the fundamental dimensions. So, for these n number of variables x1, x2, x3, xn, we need to describe by 1, 2, 3, 4. Let us say 4, or it may be 2, it may be 3, it may be 1. So, if these fundamental dimensions m required to describe these n number of variables, then these n number of variables can be written in terms of n minus m dimensionless terms or n dimensionless pi terms, independent pi terms. So, this equation may be written as f, capital F, because now we have changed these variables, pi 1, pi 2, pi n minus 1, n minus m is equal to 0. Right. So, let me again summarize this Buckingham pi theorem. Buckingham pi theorem states that in any physical phenomena which require to be described by n number of variables, and these n number of variables can be described by m number of fundamental dimensions, then these n number of variables can be converted into n minus m pi terms. N minus m pi terms means n minus m independent dimensionless numbers, right.